Hello, today we're going to talk about polygons and the idea of perimeter and area in the coordinate plane. So being able to find the distance around an object or find out the amount of space an object takes up. So the first thing we're going to talk about is a polygon. So this is a term we use in geometry to define a closed figure that is formed by a finite number of sides. So that means we can count the number of sides. And one important thing about polygons is that the sides can only intersect at the endpoints. So as we look at the four figures on the screen here, this first object would be a polygon. It has four sides that all meet at the corners and don't intersect anywhere except at the endpoints of the segments. If we look at the second figure though, even though it is a closed figure, there are no openings in the picture, and it does have a finite or countable number of sides, we have this intersection right here in the middle that precludes it from being a polygon. The third object is closed. It does have a finite number of sides, as it has four, and the sides don't intersect other than at the endpoints. So this third figure would be considered a polygon. The last figure you guys should all be familiar with is a circle. Now, if we think about what's happening here, there are no sides to a circle. So when we look at the definition of polygon, if it doesn't have a finite or countable number of sides, it cannot be considered a polygon. So a circle is in a different classification of its own. The other thing we need to talk about at this point is the idea of convex. So in polygons, a convex polygon has sides that don't cave in towards the middle. So if we look at this first example here, this would be a perfect example of a convex polygon. All of the sides go around the outside, but none of them cave in. Whereas this third object here was a polygon, but notice how the two sides up here cave in towards the middle. So that would be considered a concave polygon. So convex, all the sides go around like normal. Concave, the sides cave in towards the middle of the object. Now, as far as polygons go, one of the first things we need to be able to do is name polygons, or, given the name of a polygon, know how many sides it has. It's going to be a very important concept, especially later on in the class. So here you have a table that tells you what the different names of polygons are. So if it has 3 sides, we call it a triangle, 4 sides is quadrilateral, 5 sides is pentagon, and so on. You need to know these names of the figures. So number of sides from 3 to 12. You need to know, like if they tell you you have a heptagon, you need to understand that that's 7 sides. Or if they say it's a decagon, you need to understand that that has 10 sides. Now they have the official names, which are all given in the chart there, but something we can also do to name figures when we want to name a polygon is we can use the number of sides the object has and then just attach gon to the end. So if I wanted to name a 9-sided object, I could call it a nonagon, or I could just simply say it's a 9gon. If I had an object that had 20 sides, I could simply call it a 20gon. So these official terms in the table have to be memorized. You have to know what they are. But if you're asked to name an object, you can also take the shortcut and just say the number of sides and attach the word gon to it. So if they give you a figure like the 2 here and say classify the polygon, what they're asking is what's the name of the polygon, so how many sides does it have, and then is it convex or is it concave? So on this first object we have 1, 2, 3, 4, 5 sides. So that makes it a pentagon, or you could call it a 5gon, and since the 2 sides on the top cave in towards the middle, this would be concave. Whereas the red figure, if we count up, has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that would be an octagon. And since none of the sides cave in towards the middle, this would be a convex octagon. So knowing how to name the figures based on sides, knowing whether they're convex or concave. Now for perimeter and area, that's the next topic that we wanted to talk about today. For perimeter and area, first of all, you have these formulas here. I want you to forget all these extra formulas for perimeter. We don't need a lot of different formulas for perimeter. When I want to calculate perimeter of any object, simply add up all the sides. Don't worry about the square having a certain formula, the rectangle having a certain formula, just add up the sides. So find the side lengths, add them up, you got your perimeter. As far as area, so area, you need to know the formula for the triangle, 1/2 times the base times the height. For a square and a rectangle, again, they have these extra formulas here that you don't need to know. When you're working with rectangles and squares, your area formula is simply going to be the base times the height. So just like a triangle, base times height, except that a triangle you cut in half, a rectangle and square you don't. So what we're going to do with these is given a figure in the coordinate plane. So if we look at the figure here, they've given us a rectangle right here in the coordinate plane. They want us to find the perimeter. So that means add up all the sides of the figure. So the first thing we need to do is figure out how long each of the sides are. So in this case, because they're horizontal and vertical lines, we can just count if we want. So from G to H on the top there, I can just count 1, 2, 3, 4, 5, 6 units long. And then I can count from top to bottom. So from G to K on the left side there, I can just count down. So 1, 2, 3, 4, 5. And I can do that all the way around the figure, so then this bottom would be 6 units long and the right side would be 5 units long. Once I know how long each of the sides are, my perimeter is just taking all those sides and adding them together. So we take the 2 6s plus the 2 5s, and if we add all that together, we end up with 22 units. Okay, so it's just adding up all the sides. If we get a triangle, same exact idea. For perimeter, we just count up the lengths of the sides. So here we have this triangle here. Now, in order to get the distances or the lengths of these sides, the vertical and horizontal, I can just count. So from A down to C, I can just count 1, 2, 3, 4, 5, 6. And then I can count from C to B, so 1, 2, 3, 4, 5. So I've got 2 of my side lengths right there just from counting. Now, when I try to go from A to B, so when I'm trying to find this length over here, the problem is I can't just count. Anytime we have diagonal lines, counting is not an option. So what I'm going to have to do here is I'm going to have to use my distance formula that we talked about last week. So if I want to find the distance from A to B, I'm going to need to take my x values and subtract them. So -2 minus 3 squared, and then my y values, 3 and -3, so 3 minus -3 squared. And so now I just calculate my distance. So in this case, -2 minus 3 would be -5, squared would be 25. 3 minus -3 would be 6, squared would be 36. And then from here, I can add the 2 values together. So 36 plus 25 is going to give me 61. And then I can take that and plug it in my calculator and get a decimal answer. So it's going to be 7 point something. We'll just call it like 7.8 for now. So from here, I can add up my 3 sides. So I can take the 6 plus the 5 plus the 7 point whatever. I'm just saying 7.8 for now. So just take the 3 sides, add them all together. So with those diagonal lines, find the distance like we did up here, plug it in your calculator and get a decimal answer, and then add up all the sides of the object. When we want to calculate area, so area is something you've probably discussed before in other classes, so we go back to this rectangle here. When I want to calculate the area for rectangles is base times height. So my base, the bottom, and the height, the up and down, I need to find those lengths like I did before. So all this time I don't need all of the lengths around the figure, just my base and my height. So again, I can count 1, 2, 3, 4, 5, 6, and then count to the top 1, 2, 3, 4, 5. And so if I want the area, I simply take 6 times 5, and we get 30 square units. So rectangles, find the 2 pieces, base and height. multiply them together, you've got your area. With triangles, so when we're looking at triangles here, the formula changes. So we talked about this a little bit ago. Area is 1/2 times base times height. So as I look at this triangle right here that they've given me, again, base is going to be either the horizontal or vertical part of the triangle. So right here I have my base along the bottom. It doesn't have to be that spot there. It could be along the side, it could be on the top. It's just whatever piece is horizontal or vertical is going to be your base. Now for height, we need a perpendicular distance. So from top to bottom, so top point D down to the bottom or my base is going to be my height as it's labeled in the picture here. So I'm going to need two lengths again. I need the base, the length along the bottom, and then the height from top to bottom. So again, I can count. So I can go 1, 2, 3, 4, 5, 6, 7, 8. And then for the height, 1, 2, 3, 4, 5, 6. And then as far as my formula, I just simply take 1/2 times 8 times 6 for a total area of 24 square units. Okay, so with area, you need the two formulas. Find the base by counting, find the height by counting, multiply them together, and then if it's a triangle, cut it in half. From there, you should be able to complete today's assignment, which is the 1.4 worksheet, which you will get in class or you can access on Google Classroom. As you work, if you have questions, make sure you ask. You can email, you can ask in class, whatever you need to do though, to figure out what's going on. And then again, once the answer keys come out, make sure you check those and make sure everything looks good there.